Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of September 4th, 2023 this time around. So really right now, the planets are putting on a pretty good show for us, especially later at night. By about 11 o'clock each evening, Jupiter and Saturn are well up in the southeastern sky, and the brightest objects in that direction, and really look great. So go out, look and find Saturn and Jupiter as the two brightest objects when you look in the direction of the southeast, unless the moon's there, which the moon is early in the week. So on the evening of the 4th into the morning of the 5th, so starting about 11 o'clock on the evening of Monday the 4th into Tuesday morning the 5th, the moon slides by Jupiter. So you've got a few things stacked up there in the sky that are worth checking out. The moon's about 2/3 full, so the moon's about 60 to 70% full, and it sits about 10 degrees north, about a fist width north of Jupiter. So you've got big, bright Jupiter, and you've got the moon about 10 degrees above Jupiter. Now, 3 degrees to the southeast of Jupiter. So 3 degrees would be, 2 or 3 finger widths, a couple of finger widths like that to the southeast. Uranus lies right in that region. So you've got Jupiter, Uranus, and the moon right there. And the moon being 2/3 full is bright enough that it's not doing us any favors for seeing some of these other things. But Uranus is about 6th magnitude, 5.7 magnitude right now, I think. So it's visible. It's right on the edge of naked eye visibility, a little bit below there. And binoculars are going to pull it out. And it's going to be, there aren't any stars around it right now that are anywhere close to as bright as it is. So if you get a binocular view of the moon and look to an object that's below it and to the left, south and east, you're going to see a bluish-green object. That's Uranus in there. If you need a small telescope, by all means, try to scoot in that direction with a small telescope, and Uranus should pop out as it looks distinctly bigger, less twinkly, and definitely bluer, greener than the stars around it. Great chance. With Jupiter and the moon nearby, it's a great chance to try to find the object if you've never found it before. Just to the north then of the moon, on this night, the 4th into the 5th, as the moon slides through here, is the Pleiades. We talked about the Pleiades, the open star cluster in Taurus last week, and here we are, beautiful open star cluster. You should be able to see it, even with the moon there. It's big enough and bright enough. I think you'll be able to see it. Binoculars for sure. So you got your binoculars out scanning this region. This is great. This is a great part of the sky to be checking out this week. Now, also, we have Venus coming into the morning sky. I've been watching Venus every morning, and it just gets better and better and better as it climbs into the morning sky. So Venus, by the time we get to 5 o'clock in the morning, 4:30 or 5 o'clock in the morning, Venus is definitely the biggest, brightest object looking east. So we look to the east, and we see Venus glowing there. And if you catch it when it first comes over the horizon, 4:30 or 4:45 in the morning, 5 o'clock, it's still pretty dark. And when it's still pretty dark, you will be able to recognize that Venus sits below its own open star cluster. The Pleiades is an open star cluster. Remember, these are groups of stars, a few hundred stars, that live in the disk of our galaxy. And we see these stars that were all formed at the same time out of the same kind of glass. The Pleiades is a pretty young star cluster. M67 in Cancer is an old star cluster, big old loose sprawling star cluster. Whether you can see it with binoculars, I don't know. M44 that's on up above there in Cancer as well, you can see with binoculars. But there's only about a degree. There's only about a finger width between Venus and M67 right here. So Venus and M67 are really close. So look for something with your binoculars to see if you see this hazy group of stars. You probably won't be able to see individual stars. If you see anything at all, look like a hazy patch above Venus. Your telescope will show a bunch of glittering faint stars in there. So it's worth getting your small telescope out to move from Venus to M67. But it's worth getting your telescope out to make this observation for another reason. So let's look on the 10th, the morning of the 10th, Saturday morning, not 10 a.m., but Saturday morning on the 10th, in the early morning hours of the 10th, 5 o'clock in the morning, the moon comes sliding through this region. So what we just drew right here, and the moon is now only 18% full. So the moon is now less than 1/5 full. It was 2/3 full when we started back here. By the weekend, it's less than 1/5 full. Now, we may or may not know. You may have thought about this, or maybe you haven't thought about this. What's going on there is you've got the sun, and when the Earth is here, you know, the moon over here, the illuminated side of the moon is facing that way. We can't see it. We call that a new moon. When the moon is over here, the illuminated side of the moon is facing us. We see the whole illuminated side, and we call that a full moon. And if the moon's going around here, we've got a quarter moon, and so we've got a half moon, which we call a third quarter moon, but let's not get into that right now. So the moon's half full here and half full here, and it's getting less and less full as it moves around this direction, and we're seeing less and less of the illuminated side. Can you take a moment, see if you can see that geometry, to say, at this point right here, the illuminated side of the moon is right there. We see some of the illuminated side, and not all of it. At this point, the illuminated side is right there, and we see maybe half of the illuminated side. We see less and less and less of the illuminated side as, I'm going to draw it terribly here. We see less and less and less of the illuminated side as the moon gets around that direction. We see a smaller and smaller fraction of that part that's lit. And then we see a greater and greater fraction as it's waxing over on this side. So you've got the illuminated side is always facing up. I misdrew that a second ago. You got the illuminated side is always facing up, and we're just seeing a smaller fraction of the illuminated side as we go from here to here to here to here to here. Okay? You got that geometry. You picture that geometry. Now what you realize is Venus is doing the same thing. And so Venus is moving around, and so if we just use that same diagram, let's get rid of the moon and put the Earth back in here. Venus is orbiting the sun around this direction. So when Venus is over here, the illuminated side of Venus is there. We don't see it. It's new. Somewhere out in here, we see half of the illuminated side of Venus, and we see a half Venus. Somewhere over here, we see a full Venus. Full Venus we don't quite see probably because it's obscured by the sun. But we see something approaching a full Venus over here. Half Venus, full Venus. We're going to see a thin crescent Venus in here, where the illuminated side of Venus is right there, and the side that we see, the side that it's showing Earth, is there, right? And so we're seeing this small little thin sliver of the illuminated side of Venus. So Venus goes through a full set of phases just like the moon does. Key to understanding the Keplerian version, the heliocentric version, how we decided that the Earth is what planets are orbiting the sun and not everything orbiting the Earth, is this idea that when Venus is in the thin crescent phase, it's on this side of the sun, it's much closer to us, so it looks much bigger. When it's on the far side, nearly full, it's much further away from us, it looks much smaller. And this is what Galileo saw when he looked at it with his telescope. He saw that the nearly full Venus was about 6 times smaller than the nearly new, the very thin crescent Venus, and that's the exact ratio that was predicted by the Copernican Keplerian model of the solar system, the heliocentric model of the solar system. So this was a great prediction, a great test of that model to say, wow, not only does Venus go through phases, but it changes size as it goes through phases, and it changes size in a specific mathematical way that is in agreement with this Keplerian model. And we bring all of that up because right now Venus is a thin crescent. Venus is only about 15-16% full. So you go outside here, we watch the moon go from 2/3 full to less than 1/5 full. You got your telescope out because you were enjoying seeing Venus next to M67, but what you'll also see with your telescope is a very thin 15-16% full Venus. So to appreciate this, to appreciate the phases of Venus, get your telescope out there. I think you can probably actually get a sense of it with your binoculars. You can tell that it's less than half full, even with a pair of binoculars as you look at it. But the telescope's really going to show this nice dramatic crescent shape. So that's what we got. We're thinking about Jupiter, we're thinking about Uranus, we're thinking about Venus this week, and the moon as it passes through this region. And it causes us to think about geometry of orbits, and it causes us to think about the history of science and how we came to understand the ideas we understand. So enjoy the sky this week, everybody. I hope you have some clear skies. If you need rain, I hope you get some rain. And I hope you've enjoyed this, and we'll have something new for you next week. Thanks.